Hello, good morning, everyone, or it's morning in my country at least. My name is Maria Gudjonsdottir, and I am an assistant professor at Reykjavik University. So welcome to the parallel session 7.1, which is our papers from the CDIO implementation. We have online modes during pandemic, and we have three interesting presentation ahead. The first one is paper number 61, Implementation of e-Practical Lessons During Pandemic. So we have the authors Boon Sang Chu, Boon Chor Seo, Chi Seng Tan, Huang Kanlek, Cho Lang Chia, and Ser Kon Tuo. I hope I pronounced those names correctly. So we look forward to see the pre-recorded video now.
Very good afternoon to one and all. My name is Chia Chao Leong, and I am from the School of Electrical and Electronic Engineering at Singapore Polytechnic. Today, I'm privileged to represent my team to present to you the work that is reported in the paper entitled Implementations of e-Practical Lessons During Pandemic. COVID-19 pandemic that the whole world is facing has been unprecedented. It has affected many industries and caused serious disruptions to economic and social activities. Education is no exception. The COVID-19 pandemic has caused serious concerns among education providers as well as students and their parents, as all grapple with the fact that the safe management measures such as closure of campuses or reductions in class size for in-person classes would pose challenges to teaching and learning, potentially affecting student progressions and even graduations. Therefore, education institutes must adopt strategies to maintain learning continuity and academic rigor in the midst of the current pandemic. While online asynchronous lectures and synchronous tutorials are possible, practical works done in the laboratory remain a challenge, especially for engineering courses where hands-on practical is of paramount importance to training our students in terms of gaining experience in handling equipment and physical systems, bringing the gaps between acquiring theoretical knowledge and applying concepts to real-life problems. Prior to COVID-19, my school has put in place several platforms available for students to do practical learning. These include portable electronic training kit, simulation software, and equipment in the laboratory. As explained earlier, lockdown prevented students from coming to campus for all lessons, including practical. The use of e-practical videos became crucial and timely to minimize learning disruptions during lockdown. The features of the e-practical videos are live demonstrations of experiment, bite-sized information of the experiment, objective for micro-learning, categorizations of e-practical at suitable levels. E-Practical is developed with the following categorizations. In Level 1, it aims to familiarize students with the practical connections of equipments and circuits. It is likened to having a laboratory staff simply showing the wiring of the circuit or system and the connections to equipment to do measurements. In Level 2, it aims to impart higher order learning by connecting theories to the applications and explaining with narrations of learning objectives, possible faults, and troubleshooting technique, as well as analysis of experimental results. In Level 3, it aims to be able to help students to explore deeper into the topic by experimentations of different settings and conditions with the use of technology such as AR, VR. Our resolve to achieve CDIO Standard 8 in the midst of the pandemic, which emphasizes the importance of active learning methods in order to engage students directly in thinking and problem-solving activities, cannot be overemphasized. CDIO Standard 9 talks about actions that enhance faculty competence in personal and interpersonal skills and product, process, and system building skills. CDIO Standard 10 focuses on enhancements of staff teaching competence. Our technical executives are not only managing the laboratory resources, they are also contributing in the development of the teaching materials used for practical learning. Some also participate in teaching practical lessons. In the process, they need to build up good foundational and conceptual knowledge. And this is shown in the 3 competency level: basic, intermediate, and advanced in the technical executive module competency framework. In the evaluations of our work, 317 students and 41 technical executives participated in the survey. More than 85% of the students find the video useful in helping them to connect theory to practical, and they find the video also useful for them to use as reference when they need to carry out the experiment back in the campus. 85% of the students also find that the length of the videos are just right and that the content in it are informative and useful for them to understand the topic better. Qualitative feedback received from the students include: I like how the tutor demonstrated the lab experiment so that we know how to carry out the experiment ourselves. Also, I can rewind the videos if I need to clarify something without asking the teachers to repeat. Another student said, despite being step by step, I feel that it is really not the same as us doing the experiment, and I feel that I would need to actually do the experiment to be able to understand and remember the materials better. Evaluations from the staff surveys tells us that almost 100% of our staff demonstrated understanding of the rationale of e-practical development, and they show teamwork in carrying out the work. In conclusion, we take pride in training students to be competent engineers for the industry and our nations. Disruptions led us to seek new approach to continue teaching and learning, especially so when practical learning is so crucial for engineering study. E-practical brings benefit both during and beyond COVID-19 periods, giving students flexibility to learn at any time and any place, and also to complement in-person laboratory works even when the pandemic situation has. Evaluating students' academic performance show that the use of e-practical benefited students during home-based learning, as the overall module results in the COVID-19 semester were comparable to that of pre-COVID time. We have planned to further our work to attain Level 3 e-practical learning while mindful that in-person practical works still gives the most realistic hands-on training. And finally, we are most heartened when we see students becoming self-directed learners imbued with qualities such as adaptability, resilience, and self-responsibility, which are important attributes for workers of the 21st century. I've come to the end of my presentation, and I leave with you my contact and that of my colleague, Mr. Chu Boon Singh. And I thank you for your attention.
Okay. Thank you very much for your interesting presentation. Is the author here on the?
Yes, it's Chao Leong here, representing the team.
Chao Leong, welcome. Maybe you could introduce yourself again.
Yes, my name is Chao Leong, and I'm from the School of Electrical Electronics Engineering, Singapore Poly. Yeah, in this paper, we have a couple of authors, and I'm just representing the team.
Yeah, thank you, Chao. We have a couple of questions that have popped up on the chat. Thank you to those who have asked questions and contributed to a lively discussion. So one question is from Rodrigo Pascal. And the question is, how did you sense the anxiety levels of the students and its effect on motivation to learn? That's a very good question.
Okay, I suppose this pandemic situation has caused much anxiety, not only to the students, but of course to our staff as well. But throughout this whole period, especially in the last years, when we first encountered these pandemics, I think we continue to engage our students regularly, either through email as well as through online platform. So with that, we get to know how the students are doing in their learning at home. So it's a home-based learning. So we continue to also have a regular small bite-sized assessment to motivate their to assess their motivations in the learning of the subject. Yeah, so for practical, instead of not being able to carry out this practical experiment physically, we therefore also require them to learn the practical experiment through this e-practical via the video that we have produced. I hope I have answered the questions.
Yep, thank you for your excellent answer. So, Rodrigo Pascal, you are welcome to come up with a follow-up question from this. But we have another question from Suri Pumrin. What is your plan to improve the practical home-based learning for the next semester?
Yes, okay. I suppose COVID has taken us a surprise. But before the COVID happened, I think our practical is really in person, meaning that we have all the platform that is put in place, as I have explained in the video, namely the training kits that the students can purchase and even take back home to practice on certain module and certain experiment, as well as software that they can load into their computers, whereby they can continue to learn even outside of the campus. And of course, the equipment that we have in our campus, which I must say that we are very well equipped in terms of the equipments. But COVID has caused us to think, while the student cannot do the physical experiment, they need to continue to learn the practical aspect of the so-called the hands-on aspect of the module that they are doing. Yeah. So in that sense, we therefore have come up with, first of all, the video to at least demonstrate to the students how the experiment is to be connected. So I have mentioned in the video as well, there are 3 levels. So the level 1 is very basic, just a quick demonstration. So at least they got a sense of the experiment which they have missed, but now they are watching it over the video. What is the connection like? What are the equipment that is involved? Then going on to the next level, where we continue to give some connections between the theory behind the experiment and the experiment itself. So the question asked is, what do we plan to improve? So as I mentioned, we are still in level 2, meaning that to continue to complete all the experiment. I must say that we have 100 over modules in our school, and for each module there are around 8 to 10 experiments. So this is a huge amount of work that need to be done. So we are continuing to that. So of course, our ambition is to go into level 3, where we hope to tap on technology like VR, AR kind of things, so that it become more interactive. Thank you very much.
Okay, thank you. We have 2 more questions, but only 2 minutes left. So if you could answer the question from Camilla Klonowska briefly. Do students have access to the equipment?
Do the student have access to the equipment? If you are talking about when the students are back in the campus, yes, of course, they would have the access to the equipment in the laboratory. But we are now talking about COVID, where the students are all home-based. They cannot come back to the campus. Then, yes, I must say that there is no remote control of the equipment, but they are actually like learning at least the experiment in terms of the connections via the watching of the video and also understanding the experiment. Yeah.
Yeah. So the question was, during the pandemic at home, how did they have access? Yeah. Okay. So the last question before we head to the next video is from Rodrigo Pascual. Did you use the transactional distance theory to design the experience? If not, which framework helped you?
Hey, I must say I'm not exactly understand the term transactional distance theory. So, well, in our own way, we design the so-called the e-practical video in various level of engagement. So the first level would be engaging the students in terms of understanding, right? That means just to get familiarized with the original experiment which they have missed by watching a video whereby somebody actually demonstrate to them, so that they don't miss altogether the whole learning of the experiment, the practical. Then we move on to level 2. We think about, besides just watching it, we want to so-called engage the students to understand the theory behind. And as I mentioned, it also involves the explanation of perhaps how, if the circuit is not working, how to do some troubleshooting. So that means we take up some wires, some connections, and evaluate how the experiment should be done in the next level of learning. Yeah, but of course, in this whole development of our curriculum, including the practical, we use the Bloom taxonomy, whereby we go through the different levels of understanding, from remembering to understanding the concept, to applying the concept to the practical, and so on, right? So I hope that is something that we help the students to learn this module better.
Okay, thank you, Chia. So thank you very much for your presentation and your input. It's very has been very challenging for practical learning during the pandemic. How to do laboratory work or practical courses. So thank you, Gia, and we go to the next video. The title is Adapting CDIO Framework to Cultivate Self-Directing Learning During COVID-19 Pandemic. So here we have Gia again as a co-author. So please, we can start the video.
Everyone, my name is Sekun, Director of School of Electrical and Electronic Engineering, Singapore Polytechnic. Today, it is my pleasure to present on behalf of my team this paper, Adapting CDIO Framework to Cultivate Self-Directed Learning During COVID-19 Pandemic. Reference to the CDIO conference paper last year, which my team had presented, using learning analytics in molding students to become self-directed learners. We share that we will continue with the project and will be presenting the development and latest findings in this year's conference. With the eventual lockdown imposed in Singapore, the team was challenged to make a change in the way we intended to carry out the project initially. So we adopted an alternate learning ecosystems based on CDIO that inculcates a self-directed learning mindset to all its students on a virtual platform. Adapting to the pandemic situation, the project adopted an alternate teaching and learning ecosystems on a virtual platform. Through design thinking, 4 focus areas were identified as the backbone of the virtual platform: asynchronous lectures, synchronous online tutorials, e-practical lessons, e-proctoring assessments, and using real-time feedback from formative assessments. To begin with, to develop a good asynchronous online lectures in such a big and mass virtual platform scales for the first time and almost on the fly, if I can say, 2 main challenges were the limited time for preparations and staff capability to develop effective online learning materials. The school adopted a calibrated approach where different modules adapt to different competency levels based on their suitability as listed in the table here. Level 1 is about repackaging the available PowerPoints into bite size and adding voice narrations to address the immediate needs. For level 2, self-assessment checks, reflective quizzes, and readiness checks were added to level 1. Level 3, which deploy much sophisticated digital learning objects to enhance the overall learning experience. For synchronous online tutorials, the main challenge was the uneasiness and discomfort on the part of the lecturers who were doing this for the first time. But over time, my colleagues have gained their confidence and sharpened their online skills. They are now more experienced. Assistance were rendered to staff on delivering effective online lessons in a timely fashion. For lecturers with computers that do not have the writing capabilities using stylus, the school purchased computer writing pads. These were proven to be helpful in supplementing explanations with illustrations during online lessons. A newly PowerPoint add-in called class points was acquired to increase the interactions and engagement with students during online lessons. Being an engineering school, hands-on lessons are paramount in training the students to acquire the desired skill sets. Due to the lockdown, it was no longer possible to conduct face-to-face practical lessons. To narrow the gap from having full face-to-face to zero practical lessons, the school introduced e-practical in the form of online videos. The main challenge was then in converting practical lessons to online virtual lessons due to the limited time. The immediate needs was then to create videos to demonstrate, for example, the connection of circuits and systems in the experiment. With the immediate needs fulfilled, the videos were then expanded to include learning objects, troubleshooting techniques, and expected results from the experiment. At level 3, AR/VR was deployed to provide immersive practical learning experience. Now for online assessments, staff needs to acquire new skills such as online assessments with e-proctoring, which was totally new to school. There is also a need for effective change management to secure buy-in from stakeholders. Third, a need for constructive alignment between learning outcomes and teaching and learning activities with e-proctoring assessment. We wanted regular feedback on how engaged the students were in their daily and weekly learning and probed the extent of their understanding. This leads to the eventual mid-semester or semestral exams. The features of the online assessments is as follows. During an online synchronous tutorial lessons, it is important for the lecturers to know whether the students are able to cope, are they facing difficulties, are they able to keep pace with the lessons, so that the lecturers are able to introduce appropriate learning interventions in the timely fashions to enhance students' learning. With this in mind, the school embarked upon a technology-driven project to facilitate learning of students' performance by using edutech tools and data visualization software. This is how teaching staffs secure real-time feedback during the synchronous online tutorials. First, the results of the readiness quiz before an online tutorial lessons. Second, the supervised graded quiz during the lessons itself. Third, exit poll survey 30 minutes before the online class ends. These results were then uploaded using RPA for analysis to derive learning insights so that learning intervention can be introduced during the 20 minutes of the lessons. Now the survey results from the students, be it asynchronous, synchronous online lessons, e-practical lessons, e-proctoring assessments, we are heartened to note that our support for teaching and learning on a virtual platform is moving in the right directions with positive endorsements from students. In addition, I also like to share some of the areas that have supported students well in modules during home-based learning. For example, sufficient learning content, easy to access and navigate e-learning materials, clear and easy to understand online materials. So these are key factors for success. Great, now that you have witnessed how the school was able to continue the project and adapt CDIO framework to cultivate self-directed learning during COVID, let us now tie back to the big picture SDL Index measuring progression in self-directedness after 2 years into the project for the same 2019 and 20 cohort. So we are going to measure them in 3 perspectives: intrinsic motivation, extrinsic motivation, S5 to S14 dimension of self-directedness. Okay, let's dive into intrinsic motivation, S1, S2, S3, S4, extrinsic motivations. Let's look at for the same cohort who joined us 2 years ago and how are they doing now, okay, after 2 years, which is in green color. All right, you can see that from green compared with orange, in all aspects, they have made a significant improvement, all right, from 6 to 13%. Okay, this is on the 7-point scales about how well they agreed with the statements here. Similarly, they compare themselves, 2 years ago in orange and now in 2 years later in green color, how well they agreed with the statements. All right, you can see in all aspects there is an improvement from 12 to 23%. Now the conclusion, The school was glad that we pressed in and explored and adopted digitalization methods to continue SDL. With the experience and capability and confidence we gained, the school is now much more prepared to face any future pandemic threats without compromising the teaching and learning and academic rigor. I must say the pandemic has accelerated the acceptance of digitalization in teaching and learning for both staff and students. This will go a long way to cultivate the students to become self-directed and lifelong learners to ensure continual employability in the 21st century workforce. The progressive positive results from the self-assessment survey affirmed the cultivation of SDL and showing the whole school approach is progressing on the right track. Okay, finally, here are the contacts of my team members. Should you have any queries, please feel free to contact either one of us. Last but not least, I'd like to acknowledge every staff of the School of Electrical of Electronic Engineering for their commitments and contributions, and also our senior management for their strong support and guidance. With this, I end my presentation. Thank you.
Okay. So thank you very much for your interesting presentation. We have one of the authors here to answer questions.
Yes, yeah, Sir Kun here.
Yeah,
Right.
So welcome, Sir Kun. Thank you for your interesting talk. It was very interesting to learn more about the self-directed learning in your university. We have a number of questions here in the chat, so please feel free to ask the questions here. So we have a couple of questions from Rodrigo Pascual. The first one is, every student had access to VR hardware at home.
Okay, all right. For these questions, the journey is still going on. All right, like what my previous colleagues have shared on the e-practical especially. We are right now at level 2, but we have already started on level 3, 2 to 3 modules, all right, where we were using more of the augmented reality, okay, where students actually will mouse over through a software like Unity, you know, and they can mouse over the experiment process, you know, and when they mouse over that particular equipment, you know, instructions will pop up and visualizations will be presented to them so that they can actually visualize the operations, you know, and the results and the effects of the experiments. I would say that more real, if I can say, yeah. So we'll say that at this moment at a home, I think is still a distance away for every student to have that, you know, but certainly that will be a desired directions to go. But if they are in the campus, all right, and we've restricted so-called number of people, okay, and you know, in Singapore there's quite a strict social distance measure, all right, and then such virtual reality or augmented reality will come very useful for students learning. Yeah.
Okay, thank you. Next question is, did all of them have access to high quality internet bandwidth? If not, how did you help them?
Yeah, this is a very good question. So when we started, we make sure we assess through our personal tutor. Okay, so maybe to give you a context, in every class there is a module tutor teaching the subjects, as well as they are among the module tutors there will be one personal tutors. So through that network, we were able to identify early, all right, to see which students actually have bandwidth issues. Okay. All right, and so being an engineering computer, we were able to so-called loan quite a bit of number of computers to those families, you know, that need such help, you know, especially they come from a not so well-to-do family, so we render help. However, there are also some at their environment, it is really not possible for them to learn because it's not conducive enough. So in those cases, then we bring them back to campus. All right, and then we gave them space, you know, and with social distancing, you know, so that they are well protected. Okay, and then they do it in the campus online, you know. Yeah, so that's how we have provided the support to them. Now, and in my schools, we form a team of us among the authors supporters, they are all in my teams. We are the so-called core team, core teaching and learning team, where we provide teaching supports to our colleagues, because this is the first time that we experience COVID, in an unprecedented manner, and things have to turn around pretty fast, So I'm very grateful to this team, which provide the so-called 24/7 kind of a service to our teaching members. And I think it helps a lot, because the teaching members know that they are not going alone, and it is the whole schools that is backing them up to support them. So whenever when they are doing the teaching and whatever, and if they experience any problems with the students, help can be quickly rendered to them. All right. So one of the quick thing was the bandwidth issue, like the questions asked, and indeed, early interventions was able to so-called be provided, and we resolved this. So at the end, it went well. Okay, as you can see from the statistics, we have quite a good success. Yeah, and we can't ask for more. Yeah, thank you.
Okay, thank you. We have 2 more questions here. So how did you support and evaluate collaboration among peers?
Okay, I suppose the peers means the teaching faculties members. All right. Okay. So over there, all right, we every module, like what I say, is supported by this teaching core, teaching and learning core teams, which provide the support. Okay. So at the initial period, I remember we meet up with them very regularly in the e-way, all right, because we are also all separated, and we gave them those supports, and there is always a hotline for them to dial in, and to have a chat, and then that's how we provide. Okay, as for the students, okay, we also because of the synchronous tutorial, the tutor were able, to help the students and to help to watch out now for those students who falling behind, and that need help. So I think that's helpful. Okay, and you will see that in my presentations, we do have in the singles that we did quite a bit on the learning analytics, where the students do their own studies, all right, at their own time, anywhere, actually it's at their home, they are all locked up, all right, and they do self-reflective quizzes. Okay, so those quizzes and those questions, how they respond were all captured, in our systems. So when our staff engage them during the synchronous tutorial sessions, okay, our staff will already know how are their learning progress, and they were also able to quickly targeted to the particular topics, or segments of the lessons, to reinforce the learning. And thereafter, we do another check, all right, and the students do another self-reflective, assessment, to ensure that they actually have make improvement and progress. So this is how we help the peers among the teaching staff, as well as we help the peers among the students in that sense. Yeah.
Okay, thank you. Seems like you have put a lot of effort in making things work during the during the situation. It's a lot of work behind that.
It's a lot of work.
Yeah. So there's one question more from Rodrigo, and then one raised hand. So the question from Rodrigo is: are you going hybrid the next term?
Okay, at this moment, we are still in this mode, all right, where our lecture is asynchronous. So all those, like just now we mentioned, okay, those that we develop, has comes in very well. In fact, the quality of our asynchronous lessons are now better, because we gain a year to further develop and enhance. Okay, as well as our e-practical, as well as our e-proctoring assessment and so forth. So all are going there. So the students are now at home doing their asynchronous lecture, okay, and then also we do synchronous online tutorial. Okay, and in fact, just recently, a couple of weeks, previously the students were able to come back for practical. then they are not able again because of the situations of the COVID here. Yeah, so it is very fluid, and we are glad that we have gained all this capability. It's like anytime we can switch a button, we can go fully online, we can go hybrid, we can come back to campus. Yeah, so this is what has been happening for over the last 1.5 years. Yeah, so indeed, if you ask me if we are going hybrid, yes, indeed, we are now in hybrid. Yeah, okay.
Okay, thank you very much. We have one hand raised here from Parag.
Yes.
Hi, thank you very much. I'm Parag from University of the West of Scotland. Do you give students extra time if they are completing their class test or assessment from home?
Okay, so you are talking about extra time, right? Did I hear you correctly?
Yes.
Okay,
Yes.
right. So for asynchronous lectures, they are on time, on target. They can take their time, you know, and it is bite size. So imagine in the past, the students come to the lecture theater. The lecturers, you know, deliver 1.5 hour lectures or 2 hours lectures. Now you see them as a very bite size in the form of 8 to 10 parts. Okay, in between the parts, there are reflective questions. So they are supposed to attempt it. All right, and if they do well, then they progress to the next part. If they don't do well, they will be told, and they can redo it, and then or they can go back to the particular part of it, and then and watch again and see again and so forth. So they do that. All right. Now, so those they can take their time. Then they will have the prescribed synchronous tutorial. That's the facilitation time where the tutor will be there to clarify those questions. So during the reflective question, we already know the students actually where is their understanding level, as well as they also will be posing certain concepts or questions they want. And all these are all gathered before the synchronous tutorial. So the tutor is now no more, is responding to the needs, right? So they will target and then address them. Now, so with that, we felt that it is better managed because all the questions all came in earlier. Okay, and the tutor were able to prepare. Yeah, of course, there will be some certain sessions where it will not able to complete. Now, then what the lecturers will do is that then if it is just individual isolated cases, the lecturers will actually dial with them in another time. All right, because the tutor or the lecturer probably will have to move on to another lessons. Okay, so they can always arrange online together. Yeah, so this is how.
Right. Okay.
Right. So I will say that it is very flexible, but the fact that we help the students to have the opportunity to pose their questions, to reflect, and that also sharpen their self-directed learning. So throughout, if you saw the statistics, we see that the students are now more self-aware and they are more self-directed. Yeah, and that helps the learning more effective, and it is both satisfying for the lecturers as well as the students themselves. Yeah.
Right. Okay. Thank you. You feel it's more resource demanding than usual practice?
Yes, that's a good question because it is the first time we did. The staff definitely feel because they would love to be at the LT, and then one go you address 200 students, 150. All right, LT is definitely the most effective in terms of delivering, but it doesn't mean that it is the most effective in terms of learning and engagement. All right, while then when they do on this, although it's hard work, but they see more satisfactions because the students are really engaging, and then the students are more participative in that sense. Okay, and the staff need not go from A to Z. They are basically the staff can just go to right to the point and address those problems. So actually, it is more productive in that sense. Yeah. So
that's right.
So when after they do this, so the first semester when we prepared that was a more pain, but because the COVID dragged longer, so now they see the benefit. All right. And now we are in the third semester, 1.5 years, and we are still riding on what we have prepared. Of course, it has enhanced over the semesters, and we are really reaping the fruits of it. Yeah, and I think moving forward, we always have to prepare for uncertainty like this. Yeah, and we don't know when the next pandemic is going to come, so it's better to be ready and minimize the disruptions to learning. Yeah.
Couldn't agree more. Thank you very much. Cheers.
Thank you. Yes. Cheers.
Yeah. Thank you, To, for your excellent responses to the question. And we unfortunately don't have time for more questions to you. but we will switch to the third presentation here today, which is adaptive and flexible online learning during COVID-19 lockdown. So please go ahead.
Hello everybody, I am Dr. Shomo Kantimanna from School of Engineering, Technology and Design, Canterbury Christchurch University, UK. I'm going to talk about adaptive and flexible online learning during COVID-19 lockdown. The aim was to develop a multi-phased approach to mitigate the impact of challenges of COVID-19 on the learning, teaching and assessment so that the students could avail the benefits of flexible online learning, reduce isolation, increase accessibility to the learning and teaching materials and the resources as per their pace, place and mode. There were several challenges and opportunities of online learning. Among the challenges, the poor engagement in the study, hard to stay motivated during the crisis for the students, too many online resources available and difficult to find the appropriate one. The student couldn't access the library physically, even they cannot access the laboratory also. No face-to-face interaction with the teaching and technical staff. No communication with the peers, sense of isolation, digital poverty, mental stress, and so many others. Among the opportunities, student has the flexibility to study in a comfortable environment at a flexible pace and time. They have the opportunity to participate in classes from anywhere. They don't need to travel, so that will help them to go for a cost-saving online learning. They can have the access to more online resources as a substitute. To overcome the challenges and to incorporate the opportunities of online learning, we have taken few teaching and learning approaches. Those are flexible online teaching platform, create virtual practical session, virtual CDIO project session, and engineering cafe. Those initiatives help the student to learn critical thinking, hands-on skill, teamwork, project writing skill. Also, they could benefit from synchronous and asynchronous learning and mental support. For an example, flexible online learning platform help them to benefit from synchronous and asynchronous learning, from critical thinking and from project writing skill. On the other hand, virtual CDR project session help them to create critical thinking, hands-on skill and teamwork. Students learn from two modes of online learning method. In synchronous learning, they had the opportunity to attend live academic session of lecture, practical and seminar. In asynchronous learning, they could download the recorded session. Together, both these methods created an adaptable and flexible online learning platform for the students. And they have been benefited in so many areas, such as they could access the materials at any time, at any place. It is also financially beneficial because they don't need to travel, they don't need to come to the campus. It is also beneficial for the mature students because they can balance their family responsibilities while keeping their study. It reduced the engagement time from tutors. It also created re-engagement opportunity for weaker students. It is flexible for the weaker and for the key workers because students can recap those study materials at any time as per their convenience. We have also created virtual practical session using Tinkercad software. In this software, students can create and simulate virtual electronic circuit, virtual programmable circuit, embed the programming and run the simulation. So there are so many benefits of this software. Also, learning this software make them compatible for the future job. We have also delivered the CDIO projects online. First of all, we presented recent innovation to the students. After that, we created a pathway for them so that they can go from a hobby project to an industrial project. After that, we delivered the CDIO projects and took those feedback and critical reflection. To create virtual group work, we used the think, pair and share method. So it was very flexible for the student. Student can pair up and create their own group as per their convenience and deliver the projects through online. The opportunity just for one student to create the hardware circuit, whereas the rest of the team members participated and contributed to the project through other methods, such as making the circuit, developing the programming and simulation methods. We have also supported mentally and financially during the online learning, such as we have developed our engineering cafe to provide pastoral care, to create some fun activities and to provide mental support. Together, we would like to create a holistic learning method for all the students. To support their digital poverty, we have provided hardship fund from the university and we created a long-term laptop loan for the students. The engagement of the student during online learning is very encouraging. The overall attendance before the lockdown was 80%, whereas during the lockdown it was almost 70%. There are few limitations and challenges for the student because they are physically and mentally not well. Few of them have been working as a key workers, so those points have been reflected in their engagement and attendance. The percentage of grades is not too bad. As you can see, the first class, the number of student percentage is around 17%, whereas the second class is around 25%. We have received mixed response from the student as they prefer to have the face-to-face learning, but they have also enjoyed the online learning as well. Thank you.
Okay, thank you, Sumia Kantimana. Are you available for answering questions?
Yes, I am, Maria. Can you hear me?
Yeah, I can hear you. Could you turn on the video as well?
I think I've turned on the video. I don't know.
Yeah, you have. Yeah,
Okay.
hello.
Okay. Hello,
Nice
hello.
to see you, Sumia
Nice to see you too.
Thank you for your interesting presentation. It was very interesting to learn how you coped with the situation and found out solutions to deal with it. We have a couple of questions here in the chat. From Rodrigo Pascual, he said, does attendance mean synchronous or both? Like if you're
it's for the both. So
for both, yeah.
Absolutely.
Excellently. So from Surey Pumrin is a question, how many percentage of students participate in an engineering cafe?
It's not that much we expected. It's around like 30%. Because what happened, we kept the engineering cafe after 5 o'clock. So, after when the teaching sessions are over. So what happened, so most of the students, they have their own family life and so they've been engaging that. Also, because we have a lot of students who have been working in the part-time. So we can't expect them just leave their job and come back to the cafe. But yes, whenever they need. So the cafe has been running all the weekdays. So from Monday to Friday. So for 1 hour from 5 to 6. So any student want to come anytime, they can come, they can chat with us, reveal their problems. So it can be from academic, it can be from the mental problem, it can be from other accommodation problems. So any kind of problem, and we are trying to do our best to support them from every aspect. Yeah.
Okay, thank you. So we move to the next question. What is from Tan Huajo? What is the cohort size?
Oh, okay. So this case study has been implemented in one of the modules called Fundamental of Engineering. So the cohort size was only 42. So yeah, that's the case.
Okay,
Yep.
Thank you. Next question is from Joseph Foley. How did you implement the engineering cafe?
Okay, so we have a teaching software called Blackboard Collaborate. So all our synchronous learning sessions, whether lectures or practicals, seminars, even like online exams. So everything is been conducted on that platform. So we have used that platform, Blackboard Collaborate Ultra, so that all the student has the access, so they can come anytime. So and they have the link for joining, similar to Zoom, but sometimes we figure it out like from the previous experience, it's not that secure. So that's why we thought, no, better to use our own thing. So that's why we go for it. But at the same time, for few sessions like one-to-one, so the students who don't want to come in like in a group, so they want to talk to the tutors in person. So we used the Microsoft Teams.
Okay,
Yep.
thank you. Then our next question is from Rodrigo Pascal. How did you check that they watched the videos that they attended by watching?
Okay, so the videos is actually we don't encourage them like don't need to come to the session, live session, and watch the video. So we always say them it's better come to the live session, and if you think you missed something, then watch the recorded video. So so it's just kind of for them a supporting material. So all our lectures and practical session, we all have the live session. So the recorded videos is just for kind of like whoever missed it for certain reason, that could be a family, that could be a medical problem. So they can come and they can watch it and they can like benefit it. But we have the software. That software, they can measure the engagement time with that model. So whenever the student can come and whenever he left the session, and for the time they have been engaging with the module, whether they have downloaded the video. So those are the things we can write, because sometimes it happens like sometimes the student can download the video and they can watch in their own time. So it's not so it is not possible for us to see like whether they are watching or not. So yeah, but if they are watching on the online, obviously we can see it through the software engagement time. Yeah.
Okay, thank you. So one question from Tiravat Manchirchai, if I pronounce it correctly. We have used Discord to implement out cafes, more flexible for the students to create their own room, etc. Did you consider this eye problem with Collaborate, which is where you teacher? Oh, sorry. Oh, sorry. From Terabyte was, what kind of projects do you think are suitable for online class?
I think, yeah. So like this one, the fundamental of programming. So what we did after 2 weeks. So when the government regulation, like nobody can come to the campus, the campus is totally shut down. So we literally created a kit. So of the Arduino. So it's So in respect of the first question, I would say it's the online learning and stuff. It is quite ideal for students from computing and the programming and sometimes something for the electronics. But obviously, it's not. I think it's suitable for the people with the mechanical and this other biomedical stuff, because they obviously they need to have the hands-on skills. They require it. But yeah, so what we did for this module, so we created a kit. So that has like 10 type of different sensors with that one Arduino board, and there are some few other discrete electronics IC circuit. So we send to the students their own home, so they can literally practice with those things. But yes, at the same time, I would say the cost of everything was something we can afford. But obviously, we cannot afford something like a lathe machine or CNC machine, so we can't send those things at the home. So yes, so from those point of view, I would say yeah, we did because the electronics, the circuits, those are quite least expensive. So that's why we send those things to their home and they are practicing while they are doing the practical session. And obviously, they are also practicing with the software, the Tinkercad, which is quite useful. Am I?
Okay.
Yeah. So
Thank
sorry,
you.
Mike.
So there's one question here, or two questions related to the same subject. So Jens Bennettsen says, we have used Discord to implement our cafes, more flexible for the students to create their own room, etc. Did you consider this eye problem with Collaborate, which is very teacher-centered?
Yes, actually, few students told us because sometimes when they are not in that learning session, so they are doing their own time, so they have used the Discord, sometimes the WhatsApp, okay, but as a form of teaching and learning, we had to go by our own software. So we have so that's what I told you at the first time. So either we have to use the Collaborate, and we have to use uh, the MS Microsoft Teams, because there is one more thing in UK. We have to think about a lot of more things like GDPRs and stuff. So we can't because we are not sure like whether the other software is that much secure. So if something, let's say the identity come out or something, the other personal information uh, is leaked. So that could be a problem for the university as well. So that's why we can't take the risk. But I know there are some limitations with the Collaborate. I must agree with that. Absolutely.
Okay, thank you. And Joseph also, Joseph Foley said that I had similar experience to Jens and switched to Discord as well. So the question from Jens Benson again, project in a box, it's a super idea. Will you continue with this in the future?
Yes. So whether it's like we obviously we have to go with like work according. So in those modules, let's say last year we have been teaching like maths. So obviously we don't need to come to the campus for the mathematics, because we have been we can do it the online lectures and the practicals. We have been using 3 softwares: MATLAB, Minitab, and Excel. But like this programming module, what we did, we created that project in a box, and we are sending back to the students. But for the other module, let's say for the mechanical stuff like the workshop, what we did this semester, we created a blended learning approach. So throughout the first 3 months, they have been going fully online, lectures and practicals. But last 1 month, in a small cohorts of 10 to 15, they're coming to the campus. Yes, the UK government allowed us to do that, but otherwise we couldn't do that. So they came to the campus, and they have like a very extensive practical session 4 days in a week, 6 hours. So we are trying to fill all the gaps in those 1 month. But yes, that is something for those modules which is not possible to deliver fully through online. But yes, for those modules like the programming, for the electronics part, whether it's possible, we are trying to do it delivering through the online, of course.
Okay, thank you. We have only 1 or 2 minutes left, but there was a question from somebody raised their hands here before, but probably have lowered it. So we have time for one final question. Yeah, Rodrigo is asking me about the volcano near Reykjavik. That's a good question. It's still erupting. So, and CDIO next year will take place in Reykjavik. So maybe it will still be erupting by then. So I hope we will be able to meet in person there and that the volcano will be there. So yeah, excellent question, Rodrigo. Thank you. So any last question? If not, that will end the session here today. Let me see, there's one final question from Namita Maharan. In feedback and critical reflection part, what was the frequency of self-assessment online quiz? Was it after each class? It's a good question. Maybe you can have a few words on that before we finalize here today.
Not really. So because the self-assessment online quiz, because we have to create that kind of stuff. So what we did for twice in the whole semester, because we had to create that whole bank of 200 questions. and that like we also use the Collaborate Ultra, that same software, Blackboard Collaborate, for doing this self-assessment quiz. But yes, so obviously it's not possible for us to create that question bank all the time. But yes, so we did it twice in the whole semester. Not it after the every class. Yeah.
Okay.
But yes, we not in the self-assessment quiz, but we took something. But I've not talked it on a poster. But we use the Mentimeter. That's a software. So that's like a small quizzes after the class, just to kind of review their own assessment, but not in the form of a bigger quiz. But yes, in a small, like, okay, Mentimeter, you have this question, how many of you agree with that? Or like, this is an option, like, how can you reduce the RPM of the motor? What will be the options? They are putting their own answers. So this kind of small quizzes, yes, we did it after each and every class.
Okay, thank you very much. That
Thank
concludes our session here today.
Thank you, Maria.
Thank you to all the presenters and for their excellent presentation and responses to the questions. And thanks to all of you who attended and asked questions. And we had a very lively discussion here. So
could I ask the other speaker show their face on the video so that you can have the group photo session?
Okay, all the speakers who presented and okay. Are there other two here? The only one. So Sumyamana, you will be the only one on the photo then. We'll enjoy the attention. Okay.
Oh, sorry, I forgot to turn on my mic. Yeah, sorry.
Mic.
Yeah.
I think the other presenters are no longer here in the meeting. So
okay, thank you.
Yeah, so you've taken the group photo. So yeah, thank you for attending this session. We have now concluded it, and have a nice remaining conference day. Bye-bye.
Thank you. Bye.